Yes, in this video, we are going to talk about how we can create a voice assistant bot using a large language model. Can you suggest me something from Indian menu?
Hello, I'd be happy to help you with that. What specific dish from our Indian menu would you like to order? Our options include plain dosa, akki roti, idli, aloo paratha, and poha. Let me know if any of those catch your interest.
Okay, so I will go with one idli and one coke.
Great choice. One idli coming up, along with one coke. Your total comes to rupees 70. Is there anything else you would like to add to your order?
So guys, that was the highlight from the demo. So we are going to learn this whole pipeline from the scratch. In this use case, what is happening is the customer is basically placing the order using voice. The voice is basically converting into the textual data using the whisper model. So what I've done is in this example, instead of going with Whisper, I went with Faster Whisper. What is Faster Whisper? Faster Whisper is a reimplementation of OpenAI's Whisper model using C Translate 2, which is a fast inference engine for transformer models. This implementation is up to 4 times faster than OpenAI Whisper for the same accuracy while using less memory. The efficiency can be further improved with 8-bit quantization on both CPU and GPU. So this was basically the reason for going with faster Whisper instead of just going with Whisper. So I would also recommend you guys to go with faster Whisper instead of only Whisper. It will be lighter and much more faster than the Whisper model. And then we have different Whisper models here. We in our use case have used medium model. These are the requirements. We need Python 3.8 or greater, and I have used GPU. That's why I had to install these two packages also. So basically, after spending some time, I got to know that instead of individually install CU Blast and CU DNN, what you can do is you can rather have a NVIDIA CUDA toolkit, whatever version which supports your system. So this CUDA toolkit will have both these packages within itself, and this is the installation. So those who are going to run it on CPU, they can just follow pip install faster whisper and it should work. And this is the usage example, which we are anyways going to see when we are going to start going through the code part. So once this voice to text conversion happens, it goes to RAG. So now let's say, for example, the customer has placed Pepsi and pizza. So what will happen is this textual information goes to the RAG pipeline. Now I'm not going deeper into RAG because we have already discussed this in my previous videos, but just to give you a glimpse of how the data is basically flowing in the RAG, think of it like you have a textual file which has the information of this restaurant and the Indian menu, the English menu, and the beverage information is present in the textual data, right? And this textual data is getting converted into chunks and then embeddings, and it is getting saved into the Qdrant DB. Now, what is happening is that once the user, so basically, this is for the other example, but think of it like we have the customer here and asking for Pepsi, right? So what happens is the Pepsi word will get chunk and basically converted into vector, and then it goes to the matching. Okay, so the retrieval will fetch the chunk which will have all the beverages information where we have Coke, Pepsi, and some other things. Once the retrieval will bring out all the chunks which are matching with the customer Pepsi, it will go to the large language model. So this is what also happening here. So the moment the customer is basically asking for Pepsi, it is going to RAG, and then RAG is basically fetching the chunks and then goes to the Mistral large language model. And Ollama is basically a large language model framework. You can download, install multiple large language model. Now, once the retrieval retrieves the chunks and gets processed from the Mistral, the answer has to propagate back to the user, to the customer, right? So what happens is it has to get converted from the text to voice, right? So that is happening using the GTTS package. So we have used GTTS 2.5.1 It is the Google text to speech package. These are the features of it, and these are the installation instructions and quick start. And this is the code snippet to start with, where hello has been passed as a string and it's get converted into the hello.mp3 voice audio. Once we go through the code, we'll understand it better. So we can see that we have chat memory also in the pipeline, right? Why we need this? So in this use case, think of it like the customer is basically having a conversation with the bot, and the customer has placed Pepsi, right? So once the Pepsi is getting fed into the rack, and then the customer is keep on placing different items. Let's say after Pepsi, he has ordered Coke, or he has ordered akki roti or idli, whatever it is. So the conversation is not like he has placed each and every items in one shot, right? He's interacting with the voice assistant, and then bot assistant is giving some options, and then he's interacting it again with the different items, like, okay, whether I want this or that and that. So what should happen is that the bot should also have the memory of this chat, whatever it is having with the customer, so that it should not ask again and again in each and every query that what is your name, what you have already placed till now, right? So to have that capability of having the memory in it, we have added the chat memory. So we have used LlamaIndex chat memory buffer class to, retain the memory of the chat. Okay, so now that we have covered all the components of pipeline and all the packages and libraries which we are going to use, let's jump into the coding part. So here's the code in VS Code, where we have three main files. First is the app.py, which is the starting point of this application with main. The other one is voice service, which takes care of text to speech using the GTTS. And the third one is the RAG module, where we have two files. One is the AI voice assistant class, where we are providing the configuration of Qdrant Vector DB. We are creating Ollama object, providing the Mistral as a model. We are creating the service context and creating the knowledge base, creating the chat engine, and restaurant file, which I talked about while explaining the RAG. So we have this text file which we are going to feed and create the knowledge base out of it, right? So these are the three, or you can say four files which we are going to use. So first of all, you create a virtual environment. So in VS Code, you come to terminal and type Python venv, and the name of the virtual environment. In my case, it is .venv. And the moment I execute this command, I'll have the virtual environment. So I already have it, so I'm not going to execute this command. And once you have this, virtual environment ready, you can go to view and select interpreter, and then basically provide the interpreter path. So in my case, it will be inside .venv script. We have python.exe. So the moment you select it, your Python interpreter will get selected, and then the moment you click on the command prompt, you can see here the virtual environment is activated. So from now onwards, whatever you are going to install, it will get installed in your virtual environment. So because I have already done it, so I'm not going to do it. But let's say, for example, you want to, install all the requirements, then what you can do is pip install our requirements.txt, and the moment you execute this command, all these required packages and libraries will get it. Okay, so once you have done this, then you are ready to execute this application. Let's try to understand what we are doing in this main method. So first of all, I'm going to delete this chat history because we are not using this anymore. Okay, so we are providing model size in the Whisper model. So model size is nothing but the faster model. So as I said, we have medium.en model, and we are passing the other information. Let's say, for example, device. So in my case, I'm using GPU, so I have used CUDA. But if you are using CPU only, then you can change it to CPU, and then you have to change this to int 8. It's better you refer their page and get the correct information. And number of workers, I chose 10. It's an optional one. Even if you don't provide, it's okay. It will take the default one. So I'll revert back this to, yeah. Then we are creating Pi audio, and then we are providing this Pi audio PA int 16, channel is 1, rate is 16,000, and we are passing this frames per buffer is 1024. Then we are creating a customer input transcription variable, and then we are having a while loop. While code will keep on executing until and unless the customer and the bot doesn't finish the conversation, right, and place the order. What we are doing here is we are passing the audio and stream in the record audio chunk. We are creating the audio file here, right? And then after creating it, we are checking whether the audio file is silent or not. If it is silent, then we are dropping that file there itself. We are not processing it further. If it is, then we are basically getting the transcription from that audio file. Okay. So here you can see if it is true, then only you pass it on here and get the transcription. So how we are getting the transcription? By using the Whisper model. Model model dot transcribe, and then we are passing the file path where the audio file has been saved, and we are getting the transcription. So once we get the transcription, we are basically removing the audio file. We don't need that file. So we are going to generate file again and again. So why the audio file is going to get create and we are going to delete it again and again. So think of it like this. So the customer is keep on talking with the bot, right? And the conversation will be always like once the customer will talk, that time the bot will listen to the customer, right? What he needs, what kind of items he need to order from the menu, right? And when the bot is going to talk back, reply back on the customer's query, the customer has to be silent, right? Customer at that time is listening, like what the bot is replying. So all these conversations will be the chunk of audio. So let's say a customer is saying hi. So that will be one chunk of audio. It'll go through all the pipeline, and then in reply, the whole application will generate something in text, and that text will get replied by the bot using the voice conversation, right? So this is how the conversation will get exchanged. So that means that we are taking 10 seconds of the audio from the customer, and then we are going to get the transcription from that particular audio, right? And once we get the transcription, we are deleting that audio chunk file. Okay. And then we are basically printing the customer's transcription. Then we are passing this transcription into the interact with LLM function. So let's quickly check what is happening in the chat. So before that, once the AI voice assistant object is going to get created, right, which is happening in app.py itself. So you see here, we have the AI voice assistant initiation of the object on a class level. So that means it is going to execute at first, and once it will get execute, that means that while executing, we are creating the quadrant client, we are creating the Ollama object, we are passing the Mistral, and we are providing the request time as 120 seconds. And then we are also creating the service context, okay, and passing the large language model, and then embed model will be the local one. Then simultaneously, we are creating the knowledge base also. So in the knowledge base, what we are doing is we are passing this restaurant file. Restaurant file is nothing but the information of the restaurant. So it's a Bangalore kitchen, which is again a hypothetical kitchen. It doesn't exist, which is in Whitefield, Bangalore. And we have an Indian menu, we have English menu, we have some beverages. So once this gets executed and we get the documents, we are passing these documents, and basically the conversion of these documents into chunks and then vectors, and then eventually, right, I mean, it is getting saved in the Qdrant DB. So we are going to see that also while executing this whole application. Then the knowledge base is getting created. Okay. So that is what is happening in the create knowledge base. Then we are creating the chat engine. So in the chat engine, we are using the chat memory buffer because, as I said, we are not only using RAG, but we are also using the history of the chat so that the information which has been exchanged by the bot and the customer should get saved. And we are also using chat information in the interaction between the customer and the bot. Okay. And we are keeping the token limit as 1500. So we also want the conversation history in the memory. That's why we are using as chat engine rather than as query engine. So when we use query engine, we can't keep the memory. That's why we are using chat engine passing the memory option here as a chat memory buffer. We'll keep the chat mode as context and memory as memory of chat memory buffer. And then we are providing the prompt. So prompt is nothing but this is the prompt which we are using. Okay, so you are a professional AI assistant receptionist working in Bangalore's one of the best restaurant called Bangalore Kitchen, and ask question mentioned inside square brackets. The square brackets we have mentioned some questions like ask name and contact number, what they want to order, and end the conversation with greetings. And if you don't know the answer, just say that you don't know. This is basically for avoiding the hallucination. And then provide the concise and short answer, not more than 10 words, and don't chat with yourself. Yeah. So, um, yeah. So that was it about the AI voice assistant. Let's go back to the flow of while loop. So once we have the output from the large language model, right, we are checking whether the output is valid, and then we are stripping it, and we are playing. We are basically passing this text into play text to speech. So in the play text to speech, we are using again the GTTS, and we are using Pygame because Pygame is used here to initiate and load and play. So this is also one of the requirements which you have to install as a package. Right? Now that we have gone through all the files and understood the code part, let's run the application. So we are going to type Python, but before running this, let's run all the required applications. So we are using Ollama. So we're using Ollama, so we have to run Ollama. We are using Qdrant as a vector DB. So we have to run the Docker to basically run the Qdrant. So you can go to ollama.com and download their software. So they have software for Mac, Linux, and Windows, and they have this model list. So you can install any of these models in your device. So we have downloaded the Mistral. They have Mistral, Llama 2, Gemma, and all the popular models available. And to have a better understanding, you can go through their GitHub and go through their README, go through the quick start. So we'll quickly go to command prompt. We'll type Ollama Mistral. We want Mistral model, and we are going to run one command where we are going to say Ollama serve. So this is giving me the error saying that only one usage of each socket address. That means there's something running on 11434. So what we'll do is for Windows, we can go and check all the processes which are running on this. So now we know that these are the processes which are running. So we can terminate this using a kill. So all these processes have been killed. Now if I say Ollama serve, it should work here. So what we have done is basically we first ran the Mistral on Ollama framework, and now we are passing the Ollama serve so that we can run the inference server here. So inference server is running here, and our code will utilize that server using this Ollama. I have to go to desktop Docker Next, we are going to run the Qdrant server. So to do that, we have to have a Docker installed on our device, and you have to basically pull the image of Qdrant and run the container on this Docker software. So I'll quickly show you how to do that. So if you come to Qdrant.tech, it will give you a brief about what is Qdrant Vector DB and how to run it using the Docker commands. And it also has a quick start guide. You click here, you will get the procedure to download and run the image and how to run it on local 633 port. And there is also a step-by-step tutorial here. So please go through this so that you have the basic understanding of how you can run this vector DB. Apart from that, let's say for example, if you don't want Quadrant Vector DB, what you can do is you can go for the alternate options. For example, DB is there, VB8 is also there. So it's up to you. It's just that you have to do few changes in the code and you'll be done. Okay, so let me start this Quadrant container. So you can see the status is running. And if I go to localhost 6333 dashboard and collections, you can see there is only one collection right now, collection DB, the kitchen DB. I'm going to delete this because this is the collection which we are going to create using our application. So if we go back to our code, I'll quickly clear that. So the moment we run this application, the restaurant file will get extracted and it basically create the knowledge base. This knowledge created successfully. If you go to the localhost 6333 dashboard and collections and refresh the page, we can see that the knowledge DB collection has been created. And this is the text node. We can see the content of the file here, plain dosa, akki roti, all these with the pricing information is available here. If you go to the info part, we can see there is only one vector because the file is relatively very small, right? I mean, we are using RAG just to have, the pipeline so that, let's say in our use case, it's a very small file, but in some use cases, it could be huge. There might be multiple, chunks. And in that case, you can see a lot of, vectors here. So in our case, because it is small, so we have only. Hi, do you have idli?
Yes, we do have idlis on our menu. Would you like to place an order for that? Additionally, may I have your name and contact number, please?
Yeah, so my name is Ayansh and my contact number is 999
Hi, Ayansh. Thank you for sharing your name and contact information. Let me confirm. You would like to order idlis from our menu, correct? What else would you like to add to your order? If anything, from our Indian or English menu or beverages? Also, please note that all our orders are prepared fresh and it might take some time for the food to be ready. Would you prefer to wait at the restaurant or have it packed for takeaway? Lastly, do you have any dietary restrictions or preferences we should keep in mind while preparing your order?
Yeah, so I'll only have one idli and I'll have one Pepsi and that's it.
Understood, Ayansh. You would like to order one idli from our Indian menu and one Pepsi from our beverages section. Correct? Your total amount comes up to rupees 90. Is that correct and you don't require anything else from our English menu at this time? Also, please note that due to high demand, there might be a wait time for the order preparation. Would you prefer to wait at the restaurant or have it packed for takeaway? Lastly, we are happy to accommodate any dietary restrictions or preferences you may have. If you have any specific requirements, please let us know before placing your order.
So I think the calculation is wrong. It is not 90. It should be 60.
Apologies, Ayansh, for the mistake in the previous calculation. One idli from our Indian menu costs rupees 20 and one Pepsi from our beverages section costs rupees 40. So, your total amount comes up to rupees 60. Is that correct and you don't require anything else from our English menu at this time? Also, please note that due to high demand, there might be a wait time for the order preparation. Would you prefer to wait at the restaurant or have it packed for takeaway? Lastly, we are happy to accommodate any dietary restrictions or preferences you may have. If you have any specific requirements, please let us know before placing your order.
Thank you. That's all from my side. I'll prefer to have it at the restaurant itself.
Thank you, Ayansh, for confirming your order and preference to dine in with us. Your total amount comes up to rupees 60 for one idli and one Pepsi. We will prepare your order as soon as possible. Please let us know if there is anything else we can help you with in the meantime. Have a great day at Bangalore Kitchen.